Hello, everyone, and welcome back to Simulation World. Our keynote presentation today is by Dr. Prith Banerjee, the Chief Technology Officer of Ansys.
Welcome to Simulation World. My name is Prith Banerjee and I'm CTO of Ansys. I'm responsible for setting the long-term technology strategy for the company. Ansys helps companies around the world design and develop the most amazing products, from computer chips to rocket ships. Companies use our technology to engineer and test products completely in the digital domain without the need for costly and error-prone physical prototypes and experimentation. We call this approach simulation-based product development or software-based virtual prototyping. As a result, we enable our customers to drive top-line revenue growth by designing better products and bottom-line cost savings by reducing the cost of R&D. Our customers are the most innovative companies in the world, in industries as diverse as high-tech and semiconductor, aerospace and defense, automotive, industrial, and energy. These customers are trying to innovate and solve incredibly complex challenges in problems like 5G, autonomy, electrification, and industrial Internet of Things. Today, I will share the long-term technology strategy for Ansys. Ansys was formed about 50 years ago with our core mechanical and structural analysis software by solving second-order partial differential equations called Euler equations using the finite element method. Subsequently, we acquired the ability to solve fluid dynamics problems by solving Navier-Stokes equations. Then we acquired the ability to solve electromagnetics problems by solving Maxwell's equations. So over the years, we have now acquired the ability to provide the best of breed individual physics solvers for our customers. We continue to innovate in each of the solver areas every year. In recent years, our customers have asked us to solve multi-physics interactions, where we can model the fluid structure interactions or the fluid structure electromagnetics interactions. To support our activities, we have created a platform that allows our individual solvers to interact with each other using strong coupling, weak coupling, and medium coupling. This platform allows our solvers to run on the desktop, on-prem data centers, on the private cloud, and on the public cloud. Our Ansys cloud runs on Microsoft Azure. Finally, we acquired last year a company called Granta, which allowed us to provide a materials intelligence platform. This platform allows us to integrate more than 30,000 materials properties to drive the detailed simulation of our structural analysis solver, our fluid solver, and our electromagnetic solver. No other simulation platform in the industry has the depth and breadth of our simulation capabilities. Finally, we are allowing our customers to innovate and solve incredibly challenging problems in areas like 5G, autonomy, electrification, and industrial Internet of Things. We are therefore starting to build comprehensive solutions for autonomy, working with BMW, for electrification, working with Volkswagen, with 5G, working with eSilicon and LG, and IIoT and digital twins, working with customers like EDF and Kaiser. While I have highlighted some of the breadth and depth of our solvers in the last slide, let me now explain our long-term technology strategy that has 8 areas of investment. First is AI and machine learning, where simulation is used to train AI methods such as autonomous driving, or AI is used to improve simulation such as physics-informed neural networks. Second area is that of platform for multiphysics simulation, where we are providing robust multiphysics simulation to enhance what is called multidisciplinary optimization. We're also building microservices for simulation for tasks such as pre-processing, post-processing, meshing, various solver methods, and the like. Third area is that of hyperscale simulation. Our solvers use different forms of parallelism: GPUs, shared memory multiprocessors, MPI, message passing, task-based. We are looking at using all forms of parallelism across all our solvers. We're also looking at quantum computing to accelerate our solvers. Fourth area is that of predictive robust design. Our customers are building products using materials. Those materials have variations. So we are allowing our customers to do predictive design, robust design in the presence of uncertainties in materials. And we are providing a full validation and verification flow in the presence of uncertainties. Our fifth area is that of digital and physical worlds. We are using AR and VR, augmented reality, virtual reality, to try our simulation and bring essentially the digital world to the physical world, and IoT and connectedness to bring the physical world to the digital world. Our sixth area is that of digital transformation. Many of our customers are going through a digital transformation journey. We are partnering with them on their journey using technologies like model-based systems engineering, the use of digital threads, digital continuity, and digital twins. Our seventh area is that of computational methods for new areas, such as integrated computational materials engineering, such as computational chemistry, drug design, healthcare, and photonic ICs and 3D IC design. Our last area is that of looking at the future of simulation, where we are looking at machine language-based partial differential equation solver. We are looking at generative design. We are looking at integrated simulation, synthesis, and verification. Very, very exciting areas. Let me spend some time on going into a little bit of detail on 4 of these areas. First one is AI machine learning applied to simulation. So as we look at AI ML, we have looked at 4 types of values that AI ML will provide to our customers. The first one is customer productivity. Turns out when our customers use our Ansys solvers like Fluent, they have to set between 100 to 500 different parameters to run Fluent in the most robust, fast, highly accurate manner. An advanced engineer in one of our customer locations knows exactly which parameters to set. What we are doing with AI ML is to watch what a human designer is doing and automatically learn the use of those settings across our solvers. For example, on the right-hand side, I'm showing some early results on our linear solver called AMG, where we have used Bayesian learning to automatically set the parameters. And using that, we have been able to reduce from the default setting by about 20%. Our second use case is that of augmented simulation, where using AI ML, we are able to accelerate our simulation. For example, the use of physics-informed neural networks applied to heat transfer, we have been able to show how pin methods accelerate simulation by 100 times to 1,000 times. And the picture on the right is showing the results of numerical method simulation as well as the pin methods. And you can see the results are very, very similar while they're running 100 to 1,000 times faster. We also have done some phenomenal work in what is called machine learning-based partial differential equation solver. Very, very exciting areas. The third area is that of revolutionizing engineering design, using generative design, using topology optimization to drive better design. And the picture on the right is showing an example of topology optimization. The fourth area is that of business intelligence, where we are partnering with our customers to do resource predictions to guide them as to how many cores they'll use on running the simulation or how many gigabytes of storage they'll need on the cloud. Let's spend some time on the second area, that of platform, which is a very, very exciting area. As I mentioned, we have different solvers. Our Ansys mechanical solver solves structural problems for our customers. Our Fluent solves fluids problems for our customers. Maxwell and HFSS solves electromagnetics problems for our customers. Now, we have essentially brought all these solvers together on our platform using the latest Python interfaces to allow our customers to do true multiphysics interactions, right, across our solvers. And we provide strong coupling within the solver iteration, medium coupling across our solvers, and sort of the weakest coupling using reduced order methods. We are also providing the ability to submit our jobs on-prem, on a private cloud, on a public cloud. So how do you do that? So all the data center services are provided as part of the platform. Now we take it all, and essentially we are now providing through our platform entire solutions with autonomy, right? Working with the likes of BMW, right? We are providing a completely autonomous vehicle simulation capability, right? Which ties in scenario generation with vehicle simulations and different LiDAR simulations and sensor simulations and camera simulation. We are also doing 5G simulation for allowing our customers to do what is called multiple input, multiple MIMO antenna designs. Similarly for electrification and for digital twins and IIoT. Very, very exciting work on our platform. Let me now talk about high-performance computing. As I mentioned, our solvers over the years are very, very accurate, but they take a long time to run, right? Some of the solvers take 10,000 hours to run. In order to speed things up, we have been able to use high-performance computing to accelerate our solvers. So the picture on the left is showing Fluent, one of our leading sort of fluid dynamic solvers, right? How they have been able to scale over the years, right? So our latest release shows Fluent running on 200,000 cores in a scalable manner, right? So 200 times faster running on 200,000 cores using MPI. Very, very exciting work using MPI on Fluent. The middle chart is showing Ansys Mechanical, which is an implicit solver and which is very, very hard to parallelize. But we've been able to use the combination of shared memory multiprocessing and MPI to accelerate even Ansys Mechanical. And this is showing our latest results on 4,000 cores. But let me talk about the future. The future is about building exascale machines, with these machines now being designed for at the Oak Ridge National Lab or Lawrence Livermore Lab. We'll have fat nodes. They will have multiple cores at each node. They'll have multiple GPUs at each nodes, and essentially allow for domain decomposition and using MPI across the nodes. So we are at Ansys working on high performance computing for these exascale computers of the future to leverage the finest grain parallelism across GPUs and shared memory, and using coarser grain parallelism, right? Message passing parallelism across the nodes, and then using task-based parallelism using our Cscape platform, where we have the ability to simulate 100 billion transistors, right? In a truly scalable, memory scalable, and processor scalable manner. The last area I will highlight is that of healthcare. This is a new area for Ansys. So the reason we are looking at healthcare is a very simple reason. When you look at the total R&D spend across all verticals, it's about $1 trillion. And about 2% of the R&D spend is in simulation, which is what provides us the sort of the $20 billion simulation market where Ansys plays in. Now, it turns out that simulation has been used in all verticals like automotive and aerospace and defense and oil and gas and energy and so on. However, it has not yet been used significantly in the healthcare area, where the simulation spend is more than 240 billion. We plan to change that, right? And we want to help in this industry to reduce the time to market, right? Which takes about 10 to 15 years to come up with a new drug discovery, right? And with cost of about $2.5 billion, as we are now seeing with the COVID crisis, it's taking such a long time and so much cost to invent a vaccine for COVID-19, right? Imagine if you could do drug discovery, right, using simulation, essentially replacing the need for clinical apps, right? Clinical trials and so on. So we have identified 4 broad areas for Ansys to contribute in the healthcare area. The first one is biopharma, working with the likes of Amgen or Novartis or other companies, right? As they're doing drug discovery, can we enable them, can we help them with computational chemistry, computational drug design and healthcare and so on in that area? Or in drug manufacturing, can we help them in drug delivery, drug development? All of those areas, and answer is yes, Ansys can help the biopharma companies. The R&D spend is very large, about 182 billion. So we see a tremendous opportunity for Ansys to contribute in the biopharma areas. The second area is that of medical devices and hospital equipment. Medical device companies like Medtronic and Stryker, right? So they are inventing new things like pacemakers and so on. And hospital equipment companies like GE and Siemens, they're coming up with the new CT scanners and X-ray machines. We plan to partner with them in their new sort of product development of medical devices and hospital equipment. The third area is that of clinical apps, which is a whole new area, right? As surgeons provide surgery, right, for an eye surgery or a heart surgery and so on, we want to provide clinical applications to help the surgeons to make the right clinical decisions. It's the area of clinical apps, very, very large market, where we'll take patient-specific data on imaging and tie in with a simulation and help the doctor in providing the right surgery. Exciting areas. And the fourth area is that of digital twins, where we are helping to provide digital twins of different hospital equipment. So in summary, what we have covered is our broad simulation platform across our different solvers, and we have provided you a glimpse of our long-term technology vision across these 8 areas, and we have provided a little bit of depth in AI/ML, in high-performance computing, platform, and healthcare. Thank you so much for your attention.